Okay, today we are going to calculate area and perimeter, which will lead us up to surface area, and then next time we'll talk about volume. So remember, perimeter is the distance around the outside of a shape, whereas area is the space inside of a shape. So we're going to find the perimeter and area of the following. So the first one they give you is a rectangle. Sometimes if it's helpful, I draw a picture. It tells you it has a length of 8.3 and a width of 2.7 feet. Okay, so if I start and I ask you what the area of that rectangle is, you're going to simply take the length and you're going to times it by the width. So we get 8.3 times 2.7, and we end up with 22.41 feet, and because it's area, we have it squared. Whereas for perimeter, we are going to add the sides together. So you could do something like 8.3 plus 2.7, and you know these other two sides are also 8.3 and 2.7, so add up all the four sides. But it's a little bit easier if you just say, okay, well, there's two sides that are 8.3, so I'm going to do 8.3 times 2 plus 2 times 2.7. And I can type that all on my calculator at the same time, and I end up with 22 feet for perimeter. So remember, perimeter is just the same units, and then area is it squared. Okay, so if we're talking about area of a square, we're going to take the two sides, which is 5, and you know it's certainly 5. So 5 times 5, or you could say, hey, that's 5 squared. So you get 25 inches squared. Okay, perimeter, you're adding up the four sides, which are all 5, so you really have just 4 times 5. So we get 20 inches. Okay, with a triangle, for the area, I think students like to use the formula base times height divided by 2, though. So it's half the area of a rectangle. So be a little careful here. Your base is the entire length from x to z, which when I add 6.4 plus 3.6, I end up with 10. So we're really doing 10 times our height of 4.8 divided by 2. So here we get 48 divided by 2, and you get 24 centimeters squared. As for with perimeter, you're going to add up the sides. So we have 8 plus 6, and then the base is 10. So we end up with 24 centimeters as well. That doesn't always happen, but it did happen in this case, just for the record. Okay, on the next one, we're doing the area and perimeter of a circle. So area and circumference. Remember the formula for area of a circle is pi r squared. So be careful, because this gave you the diameter. So to find the radius, it's half of the diameter. So it's 7.5 in this case. So here we'll have pi times 7.5 squared. So you end up with 56.25 pi. This is like an exact answer, right? Remember last time we talked about exact versus approximate answers? And if I wanted to approximate that, I'm going to go ahead and type in my calculator with pi, and I get 176.71. Both of these have a label of inches squared. Last time we kind of had you leave your answers as exact. Today, it's going to be fine just to write them as the decimal equivalent, decimal approximations. Okay, perimeter in this case is the same as your circumference. So circumference is just the fancy word for perimeter of a circle. So we have 2 pi r, which is the same, it's just pi times the diameter. So what you think about it as a 2 pi times 7.5, that's just the same as just pi times 15, right? So 15 pi. In this case is inches. If we approximate that and type it in our calculator, we get 47.12 inches. Okay, this next one, we're going to do both area and perimeter. I'm actually going to start with, I'll leave some space for area, but perimeter is actually a little bit easier, because notice, hey, since all of these are marked the same, this is an isosceles triangle. All the sides are 12. So in this case, we're doing 12 plus 12 plus 12, or just 3 times 12. So we end up with a perimeter of 36. This would technically just be like units. The tricky part is when I'm thinking about, my area, I know my base is 12, but the problem is I don't actually know my height. I know it's this line down here in the middle, but I don't know what that is, and then I'm going to divide by 2. So the issue here is we want to figure that out. You'll notice since it is an equilateral triangle, those are both 60. I'm just going to focus on 1/2 of this triangle for a minute. So I'm going to do a little work over here on the side. So notice, if I look at this triangle, this is 60. So if this is 12, and that line splits it down the middle, 12 divided by 2 means this side is 6. So it's up to you. There's a couple different ways, but I need to somehow solve for this h. So I could use Pythagorean theorem, right? I could use like 6 squared plus h squared equals 12 squared. So 36 plus h squared equals 144. Subtract the 36, h squared equals 108. Divide both sides by the square root, and as you take the square root of 108, you end up with h is 10.39. That's one option, right? Option 1. Another option is you could say, okay, well, I know my trig functions, right? Like, so maybe you use this 60-degree angle, and you do, okay, this is opposite, hypotenuse, adjacent. So maybe I decide to use like, hey, my opposite and my hypotenuse. I could do something like sine of 60 equals h over 12, times both sides by 12. Once again, h equals 10.39. The last way you could think about it is as a 30, 60, 90-degree triangle, right? So if you've got the long side, the hypotenuse is 12, then that means the short side is 6, and then the long side, remember, is 6 square root of 3, which is also about 10.39. So it doesn't matter which way you do it, but one way or the other, you have to find that height. So we're going to do 12 times 10.39 divided by 2. When we end up with an answer, we either get, depending on how kind of you estimated, 62.34 or 62.35 as kind of your answers, depending on when you rounded, so units squared. So just be aware, yes, those answers differ slightly, but in essence, they're similar enough. Okay, so now let's get to the fun part, which is surface area. So surface area is the amount of space it takes to cover a 3D figure. So what I've kind of done here is broken down these shapes for you so you can see them as like a two-dimensional figure. And we had a great conversation in class about, hey, just so you know, all the surface area are going to be units squared because we're breaking down this three-dimensional object and just finding the area of the outsides. Okay, so you notice a cube has 6 faces, meaning there's 6 sides, and all those sides are squares. So the cool thing about that is if I want to find the area, we kind of use this notation. We put a little square and put a little a for the area of the square. I'm just going to do 3 times 3, so I get 9. So this is 9 centimeters squared. But if you have 6 of them, as you compute surface area, you can do 6 times 9, so you get 54 centimeters squared. Okay, a triangular prism. In this case, there are 3 sides, 3 rectangles and 2 triangles. So it has a total of 5 sides. And probably the hardest thing about this is not all the ones on the homework have it broken down for you like this. So you're going to have to do a little visualization here to see what's going on. And 2 of the faces are triangles. Okay, so let's start off. We first want the area of the triangle. So we're going to do the base, which in this case is 4. It doesn't matter. The one on the right and the left are the same exact triangle. That's the cool thing about these shapes. Lots of symmetry. So we're going to do 4 times the height is 3 divided by 2. So the area for just one triangle is 6. Okay, then we've got the rectangle. The area of the rectangle has a length of 7 and a height of 4, so the total area is 28. So as we're thinking about surface area, we've got 2 triangles, which are each have an area of 6, plus 3 rectangles, which each have an area of 28. When I multiply those all together, I get 96 meters squared. Okay, next one we got a rectangular prism. So in this case, there are 6 sides, 6 faces, and they are all rectangles. Unfortunately, though, they're not all the same rectangles. So let's just take a look. There's a few different rectangles here. So let's go through. So like, for example, if I look at just this red one here, right, you're going to have 7 times 4, so we get an area of 28. So this is an area of 28, and you'll notice also this one's an area of 28. So there's like two rectangles here, right, that both have 28. Okay, on the next one, if I look at this top bit, I've got a length of 3, and this is technically a width of 4, so this would be 12, right? 3 times 4 is 12. And you'll notice that actually is like these two side ones. And last but not least, we've got a width of 3, right? And then a height of like 7. So 7 times 3 is 21. And then that ends up being these other two. So you'll notice that each of these rectangles appear twice. So as I'm figuring out the surface area, there's kind of two ways to think about it. You could add them all up and then times by 2, but I think most students think about it as like 2 times 28 plus 2 times 12 plus 2 times 21. So you end up with a total of 122 feet squared. Okay, the next one is a square pyramid. We call it a square pyramid because the base is a square, but then we've got like the pyramid coming up. So it has 5 faces. It has a square base, that's why we call it a square pyramid, but then we also have 4 congruent triangles. So, area of the triangle. The base, which is 4 again, times the height, which is 3, divided by 2, so we get 6. And this time our square area is just 4 times 4, or 4 squared, so we get 16. So as we go ahead and find the surface area, we have 4 triangles, right? 4 triangles, so it's 4 times 6, plus the square is 16. So we end up with 40 inches squared. Okay. This last one is a cylinder. And I kind of left this here, like I didn't break it down for you, so you're going to have to kind of visualize it yourself. So think about it. We've got a circle on the top, a circle on the bottom, and if I unfold this middle part, like think about slicing that can down the center and like literally unfolding it, you'd have a rectangle. So our circles both have a radius of 4. So the area of the circle is simply pi, your 4 for your radius, right, squared. So you get 16 pi. You can totally use a decimal at this place if you want, but there's kind of a reason. Our answer could be in terms of pi if we wanted, but the decimal will be great for the answer. Okay, your rectangle has a height of 15, and think about it this way. As you look at that rectangle that we split in half, notice how it goes all along the top. So this length really ends up being the circumference of the circle. So in this case, the length of it is c equals 2 times pi times 4, so equals 8 pi. So if I wanted to go ahead and compute the area of the rectangle, I'm going to take the length, which is 15, times the width, which is 8 pi, and I end up with 120 pi. So your surface area here is, you've got 2 circles, so 2 times 16 pi, plus 120 pi for the rectangle, and we end up with 152 pi, which is approximately, if you type that on your calculator, 477.52. Remember our units, centimeters squared. All right, that's a wrap. Good luck with your assignment.